Okay guys, in this video we will be continuing the problem on logistics regression, okay, in which we found the test statistics g square that was equal to 16.4, okay, using the formula, okay, minus 2 into the log likelihood of the reduced model minus the log likelihood of the full model. Okay, so these two values were given to us, okay, and we found it to be 16.4. okay, so this statistics, okay, the LRT, okay, the likelihood ratio test statistics, this follows the chi-square distribution. Okay, you must know that it follows the chi-square distribution. Okay, and this is the fundamental result of the likelihood theory, which is also called the Wilks theorem. Okay, so now we will continue into the third part, okay, part C. Okay, and this part states that to define the sampling distribution and degrees of freedom, and degree of freedom df. Okay, so under the null hypothesis, the g square, okay, which is the likelihood ratio test statistic, okay, it follows the chi-square distribution. Okay, so this is the sampling distribution. Okay, so it follows the chi-square distribution. Now to find the degrees of freedom, so the degree of freedom in this case, okay, it will be equal to the number of parameters in full model minus the number of parameters in reduced model. Okay, so the parameters in full model are beta naught and beta 1, while in the reduced model we only have beta naught. Okay, only the intercept term we have in the reduced model, while in full model we have two parameters, the intercept with explanatory variable. Okay, so 2 minus 1 is equal to 1, so this is the degree of freedom df. Okay, so that is how we find the degree of freedom. Okay, it should be the number of parameters in the full model minus the number of parameters in the reduced model. Okay, so it depends on the case. Okay, it depends on the problem. Okay, so you should see what's given in the problem, okay, and then calculate it accordingly. Okay, so now we come to the last part, okay, part D. Okay, and it says that to find the at 5% significance level, okay, decide whether which model is better. Okay, so decide at 5% significance level, okay, that is alpha is equal to 0.05. okay, which model among the two better fits the data. Okay, which are these models? The full model and the reduced model. Okay, so how we can do it? Actually, we can use the chi-square table to conclude it. Okay, so its conclusion will be based on the chi-square statistic score. Okay, so in the previous parts we found that the likelihood ratio test statistic G square, it was equal to 16.4. okay, now we need to compare it with the chi-square value, okay, for a significance level of 0.05 or 5% and degree of freedom of 1. So we need to look at in the chi-square table. Okay, so upon looking it in the chi-square table, okay, we find out that the chi-square value for a significance level of 5% and degree of freedom of 1, it is equal to about 3.84. okay, now we need to compare this value with the test statistics of the likelihood ratio. Okay, so by comparing, we see that this G square value, okay, G square, it is greater than the chi-square value for 5% and 1 degree of freedom. Okay, 16.4 is greater than 3.84. okay, so this means that we reject H naught. Okay, the null hypothesis is rejected. Okay, we can say that the null hypothesis is rejected. Okay, so let me write down the decisions based on the chi-square score. Okay, so if G square is greater than the chi-square value for alpha and degree of freedom, okay, then we reject H naught. Okay, and if G square is less than the chi-square alpha degree of freedom, then accept the null hypothesis. Okay, so what was our null hypothesis basically? Okay, so null hypothesis was that the reduced model is a better fit. Okay, and the alternate hypothesis was that the full model is better fit. Okay, so if we reject this null hypothesis, it means that this alternate hypothesis, this is true. Okay, so at 5% significance level, okay, it depends on the significance level. Okay, so you have to look it for the significance level that is asked in the problem. So at 5% the significance level, full model is better. That is our conclusion. Okay.